Day 763 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3753, total waviness of numbers in range 2. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given two integers num1 and num2 represent an inclusive range between num1 and num2. The waviness of a number is defined as the total count of its peaks and valleys. A digit is a peak if it is strictly greater than both of its immediate neighbors. A digit is a valley if it is strictly less than both of its immediate neighbors. The first and last digits of a number cannot be peaks or valleys. Any number with fewer than 3 digits has a waviness of 0. Return the sum of waviness for all numbers in the range num1 and num2. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples. Now, before we get into these examples, I'm sure you have noticed if you've been following along with this channel, this question looks very similar to the question we did yesterday, which was total waviness of numbers in range 1. The only difference between this problem and that problem is these constraints right here, y'all. So keep that in mind. The solution will be different even though the question is the same. This is a hard problem. Yesterday was a medium problem. If you missed that yesterday's problem, day 762, I suggest you go check it out because it is the easier version of this problem. Now let's get into example 1. So in example 1, our input num equals 120, num2 equals 130. So we want to check the range of numbers between 120 through 120. So 121, 122, 123, 124, 125, 126, 127, 128, 129, 130. Boom. Now, out of all of these numbers up here, we want to count the waviness of all of these numbers, see which numbers are wavy, which numbers are not, right? So, and we already know by the output, there are 3 wavy numbers in this range. These are right here, tell us what a wavy number is. If the peak is strictly greater than both of its neighbors, or the valley is strictly less than, or a digit is a valley if it's strictly less than both of its neighbors. Both count as wavy points, right? So if it's a peak, it gets a waviness point. If it's a valley, it gets a waviness point. So let's go through these numbers and see which ones is wavy. So 120 is wavy, right? Because the middle digit is a peak. So the waviness, it gets 1 wavy point. So right here, 2 is strictly greater than 1. Let's see with the peak, strictly greater than both of its neighbors. So since 2 is greater than 1, 2 is greater than 1, and 2 is greater than 0. So this 2 right here is a peak because it's greater than 1 on the left, it's greater than 0 on the right, so it gets a wavy point. Boom. Then we look at 121, same thing with 121. 2 in the middle is greater than the 1 on the left, and it's also greater than the 1 on the right. So this is another peak, right? Because 2 is greater than both of its neighbors. Now, that's this one right here, so we get another waviness point. Now this right here gets no waviness points, right? Because this 2 is not greater than this 2, it's equal to this 2. So since they're equal, it gets no wavy points. Same with this. This 2 is greater than this 1, but it's less than this 3. No points there. Same with this. 2 is less than 4, 2 is less than 5, 2 is less than 6, 2 is less than 7. And it's important to note that it's greater than 1 and less than 7. If it was less than 7 and there was a 7 on this side, if it was less than both, then it'd be a valley that count. But since it's greater than 1 and less than 7, doesn't count. Same here. It's greater than 1, less than 8, doesn't count. Greater than 2 right here is greater than 1, less than 9, doesn't count. But then we get right here to this 3. Now look at this 3. This 3 is greater than 1 and 0, right? Boom. So we get another waviness point for 130. And in total, in this range right here from 120 to 130, there are 3 wavy numbers, so we return 3. Now, just in case that didn't make sense, let's take a look at example 2. So example 2, the range is a little shorter. It's just 198, 199, 200, 201, 202. Boom. Now let's count the waviness numbers. In this case, the output is still 3. It says 198. So once again, this 9 is greater than this 8. Excuse me, yeah, it's greater than this 1 and this 8. So boom, we get a wavy point for 198. 199, no wavy points because this 9 is equal to this 9 and greater than this 1, no wavy points. Same here, this 0 is equal to this 0 but less than this 2, no wavy points. This 201 right here is less than 2 and is less than 1. That's a valley, so we get a wavy point for 201. Boom, 201 gets a wavy, oh sorry, we down here. 201 gets a wavy point, same with 202. So 0 is less than 2 and is less than that 2, which is another valley. Sorry y'all, another valley. So 202 gets a wavy point as well, and in total we got 3 wavy points. 1 plus 1 plus 1 is 3, so our output is 3. Boom. Now just in case that didn't make sense, let's take a look at example 3. So in example 3, we have our input num1 equals 4,848, num2 equals 4,848. That's our range, but it says right here, well, the output is 2. Explanation says the number 4,848, the second digit 8 is a peak and the third digit 4 is a valley, so it has a waviness of 2. So this one number gets 2 wavy points, right? Because this 8 right here is greater than this 4 and this 4. Boom, so that's a peak. And then this 4 right here is less than this 8 and this 8, so that's a valley. So this number right here has a peak and a valley, so the output is 2. Boom, y'all. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult. It's a little lengthy because of the constraints that we're working with, but I think we'll get through it. Now, first thing we want to do is we are going to create helper functions. We have a few helper functions that we need to create, so just get ready to lock in on these helper functions. Now, the first helper function we'll create is going to be, we'll just call it, sorry y'all, trying to think, we'll just call it solve. So we'll come underneath this, we'll create a private func, call it solve, open up the parentheses, say underscore nums, colon, int, come outside of that, and we'll return int, meaning an integer. Now, if the upper bound is not positive, then there are no valid numbers. So we'll say guard num is greater than 0, else we could open up the brackets and we could just return 0. Boom. Then we need to convert this number into an array of digits in left to right order, and this will be used for our digit dynamic programming. So we're going to say let digits, colon, an array of integers, come outside of that. It's going to equal, we're going to open up the brackets, we're going to declare a variable called res, colon, that's going to be an array of integers, and we're going to set that equal to a blank array. Then we're going to declare another variable called num, set that equal to num. Then we're going to say while num is greater than 0, we're going to open up the brackets and we're going to say res.append, open up the parentheses, num mod 10. Then we'll come underneath that and we'll say num divided by, divided by equals 10. Boom. Then we'll come underneath this while and we're going to say return res.reverse and put the parentheses, then come outside of this let this right here and we're going to put some parentheses right here as well. Boom. Now we're going to create our memoization table. So we're going to come right here underneath this let and we are going to say var memo colon, it's going to be square bracket integer colon, open up the parentheses, count colon int comma sum colon int, come outside of that and we're going to set that equal to a blank dictionary. Boom. Now we need to compact our integer key for memorization using the current digit position, the second to last digit, and the last digit. So we're going to come underneath that, and we are going to create a, come underneath this, and we are going to create a function, func called key, open up the parentheses, we're going to say underscore POS colon, int, comma, underscore, second, colon, and comma, underscore, last, colon, and come outside of that, it's going to return, and we're going to open up the brackets, open up the parentheses, we're going to say POS times, POS times 11 plus second. Come outside of that, we're going to say times 11 plus last. Boom. Then we're going to come underneath this, and we're going to use our digit dynamic programming recursion. So we're going to create a dynamic programming array or depth first search. We're going to say func DFS, open up the parentheses. Just to make this clean, we're going to say underscore, that should be underscore POS colon int, comma, underscore type, colon, bool, comma, underscore started, started, colon, bool, underscore second, colon, int, comma, underscore last, colon, int. Then we're going to come right here. We're going to say returns, open up the parentheses, count, colon, int, comma, sum, colon, int. Come outside of that, and we're going to open up the brackets. And if we process all digit positions, then we formed one valid number with 0 additional waviness. So we'll come right here and we'll say guard POS is less than digits dot count, else open up the brackets, and we're going to return, open up the parentheses, 1, comma, 0. Now we're going to use the memoized result when not constrained by type by coming underneath this guard, and we're going to say let k equal key, open up the parentheses, we're going to pass in POS, second, and last. Boom. Then we'll come underneath that, and we'll say if exclamation point type, comma, let cached equal memo square bracket k. Come outside of that. So y'all will open up the brackets, and we could just say return cached. Now we need to determine the maximum digit we can place here. So we'll come underneath this, and we'll say let limit equal type question mark digits square bracket POS colon 9. So whichever one is bigger, digits or 9, right? So if this is true, then it will return the digits of POS, or else it's just going to return 9. Boom. Then we'll declare a variable called total count. Total count, set that equal to 0. And another variable called total sum, set that equal to 0. Now we're going to try all possible digits in this position. So we're going to say for D and 0 dot 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 limit. We're going to open up the brackets, and we're going to say let next type equal type and 2 and signs, D equals limit. Boom. Now, we're going to handle case 1, which will be the number has not started yet, and we place 0. Leading zeros are ignored and do not affect waviness. So we are going to say if exclamation point started and two and signs d equals 0, we're going to open up the brackets and we're going to say let child equal DFS, open up the parentheses, POS plus 1, comma, next type, comma, false, comma, -1, comma, -1. Then we'll come underneath this and we'll say total count plus equals child.count. We'll say total sum plus equals child.sum. Come underneath that and we can say continue. Boom. Now we need extra. We're going to declare another variable called extra, which will represent whether adding this digit creates a new waviness point or not. So we'll come underneath this if, and we'll declare a variable called extra. Set that equal to 0. Need another variable called next second. Next second colon. That's going to be an int. Then we'll say another variable called next last colon. That's going to be an integer as well. Now for case 2, this is the first non-zero digit. So we'll come underneath this and we'll say if exclamation point started, we'll open up the bracket and we're going to decrement next second by 1. So we're going to say next second minus equals 1. Then we're going to say next last, set that equal to D. Else, which will be case 3, is the second digit this is the second digit of the number. So we'll come right here and we'll say else if, open up the brackets. Else if second equals -1. Then we come right here and we are going to say next second equals last, and we're going to say next last equals D. Boom. Sorry, this should be a D and not T. Boom. Now for case 4 means we already have at least 2 digits and we need to check if the previous digit or the last forms a peak or valley. So come right here, we'll say else, and we'll open up the brackets again. This time we're going to say if, open up the parentheses, second is less than last, and two and signs, last is greater than D, or come outside of this 2 vertical lines, or open up some more parentheses, second is greater than last, and 2 and signs, last is less than D. Then we come right here, we open up the brackets, and we say extra equals 1. Boom, and we come underneath this. Inside the else, we say next second equals last, and we say next last equals D. Now we're going to recurse to the next position. So we'll come underneath this, and we are going to say let child equal DFS, open up the parentheses, POS plus 1, comma, next type, comma, true, comma, next second, comma, next last. Then we're going to accumulate the total number of valid numbers and the total waviness, including any new waviness introduced here. So come underneath this, we're going to say total count plus equals child.count. Boom. And we're going to say total sum plus equals child.sum plus child.count times extra. Then we need to cast the result when not constrained by type. So we come underneath this and we say memo square bracket K Come outside of that. We'll set that equal to, open up the parentheses, total count, comma, total sum. Come underneath this, and we're going to return, open up the parentheses, total count, comma, total sum. Boom. Then we're going to start the DP from the first digit. The final answer is the total waviness sum by coming underneath this, and we're going to say return DFS, open up the parentheses, 0, comma, true, comma, false, comma, -1, comma, -1, come outside of that, and we're going to say dot sum. Boom. But we're not done yet because we still need to come back up here to the main function so we can compute the total waviness. So we come right here and we say solve, open up the parentheses, pass in num2, come outside of that, minus solve, open up the parentheses, num1 minus 1. Boom, y'all, that's all she wrote. Let's give it a run, make sure it runs properly. And we got our first error right off the top, y'all. Cannot find num in scope. Oh, sorry, this should be num, not nums. So now let's run it again, see if that did the trick. Oh, we got double parentheses going on here. I've never seen that before. I don't know what's going on with that. So let's try it again. Okay, now let's see what we got. I already know it needs to be POS, not PST. So where we at, this should be POS. Boom, now let's run it again. Let's see. Okay, we got another error. This should be square bracket K, not regular bracket K. Let's run it at again. Okay, next second. Okay, now where we at? This should probably be a -1 maybe. Let me look, let me see. Let me see, y'all. This should be, actually, I think this should be equals -1. Let's see if that did the trick. Let's see. And it's accepted, y'all. That's what I'm talking about. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Boom, and look at that, y'all. 79 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the top of the middle part. This is the middle part, middle of the middle. This is the bottom of the middle. And this is the bottom of the code, y'all. And yeah, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.